So let's see about how the Databricks evolve and what is Hadoop, what is MapReduce and all right. So initially, like you know that like in traditional data systems, all the data systems used to be processed, all the data used to be processed with the single node, right? So single server, single node used to process the data, right? But as the data increased, as the data evolved and spread across to multiple sources and multiple formats, right? And still the people were depending upon only on the single node, then there was an issue of performance, right? Say suppose you have 1 GB MB data, like 100 MB data, 1000 MB data, okay, it takes some time. And if you increase like GBs, TBs, petabytes, and still if you are depending upon if you are depends on only single node, then there is a issue, right? So to overcome that problem, slowly people started exploring the multi-node or multi-processing architecture, right? So initially Google started something called MapReduce. Initially they invented something called MapReduce, so which does this multi-processing architecture, right? But there was some issues in that because of the memory issue. Because whenever so in the MapReduce, what happens is that all the task whatever it is been defined, that will be passed to multiple processes. Then processes performs the operation on the data, then returns to the control node kind of. But at the time the data, there was issue related to the coordination between this concurrent groups, and as well as the memory issues were there. Because each time the data used to be written to the specific process, the internal process, then it used to process and return, right? So there was a memory issue, like all the memory optimizations used to occur, right? Then slowly Hadoop evolved based on that. So here what happens in the Hadoop, you defines map and reduce tasks using a map reduce app API. So if you see in the broader terms, there are three steps related to the Hadoop. So first one is, yeah, user defines the map and reduce the tasks. That means, say suppose a data loading has been given like for 100 tables or 10 tables, right? So the user defines the map, how the segregation should be happened between all these 10 loading process. Then it reduces tasks using some map reduce API. Say suppose 10 files are loaded, so it reduces or it segregates all this loading mechanism into 10 different processes, right? So it reduces basically the map and reduce, right? Then there is something called yarn, the yarn component, which takes care of resources allocation and figure out where and how to run the job, right? So there is something called yarn, what it does. So if you remember in the MPP, I was talking about the control node and the compute node. Here, the similar way, the control node, you can say that yarn. Okay, yarn takes care of resource allocation. That means, so which which task needs to be. If you take an example of the same this 10 tables load, it talks about which task or which table needs to be allocated to which reduce. That will be done by the map. But what is the resource which needs to execute this data loading, okay, that resource allocation would be done by the yarn, right? So once the map reduces the data, reduces the task, then yarn takes care of resources allocation and performance. Then once the job is performed, then it should store the results to the HDFS, Hadoop file system. Okay, so HDFS is Hadoop file system where the data will be actually stored. So basically, Hadoop will have three components: MapReduce, Yarn, HDFS. So MapReduce segregate the tasks and divide the load. Then Yarn allocate the resources to all those internal processes. Then once the job is performed, then whatever the result is being generated, that will be stored back to HDFS. That is basically at high level Hadoop, right? And but Hadoop was having some limitations, like there was some in-memory issues and all. So on top of Hadoop, slowly Apache Spark has been developed. If you see here, here also the same thing will be there, the yarn and HDFS. Sorry, there is some issue. Yeah, so there is a yarn and HDFS, and the Spark core is kind of a brain for all the Apache Spark architecture, and it has some of the features or some of the APIs through which you can perform the processing on the data, right? So if you see Apache Spark, it's an open source. Actually, Apache Spark is open source. The open source application, like each company or each organization developed its own version of Apache Spark on top of this. Okay, so Azure, like Databricks is developed on that, and Azure used the same thing. They created uh, Spark pools as part of Synapse, and the Databricks, Databricks also developed on Apache Spark. So it's an open source platform. So the multiple companies developed their own application on top of it. So in a nutshell, if you see that Spark is unified processing engine that can analyze big data using SQL, machine learning, graph processing, or real-time stream analytics. So basically, it's a processing engine. So it can analyze the big data. So at the end of the day, all the data engineering world talks about the different like analyzing the big data, right? So Spark also provides such engine which analyze all the big data using various libraries. So they use Spark SQL for the data, and Spark streaming for processing the stream data, and machine learning libraries for processing or developing machine learning applications, and the graphics for where the data is there, like nodes and edges. So those kind of data will be processed with the graph. And it built on top of the Hadoop, as I mentioned. So based on the Hadoop, so to overcome the issues whatever being faced by the basic Hadoop, the Apache Spark has been developed on top of Hadoop. Open source and works on memory engine 100 times faster than Hadoop, right? So as I mentioned, it's open source and works mostly on the in-memory engine. Okay, so whatever the operations are there, those will be performed on the in-memory instead of processing on the disk. Okay, so that makes one of the powerful tool, Apache Spark. And if you compare to Hadoop, it's 100 times faster than the Hadoop. So if like Hadoop takes like some time, so this process the same operation 100 times faster. And it supports structured, semi-structured, unstructured data. So if you remember the earlier we were talking about structured, semi-structured, unstructured data. So Hadoop can perform, or Hadoop can process the data irrespective of the structure of the data.
So
right?
like,
Yeah.
In-memory processing in the sense on cluster.
Yeah, and the cluster itself in memory, like whatever is there, it's kind of a cache. In memory, it will process the data. So takes the data and process in memory and writes the results back to the disk or storage instead of performing the operation on the storage. So there will be some clusters which performs this, which performs this one. So we can see more about this in the while discussing about the ADB and creating clusters and all. And highly scalable, can process batch processing data, ML, and advanced analytics. As I mentioned, it can it can process batch data, real-time data, ML, and it can perform advanced analytics. And also it's scalable. Scalable in the sense like as the data loading increases, or the data volume increases, or data processing increases, it can scale up the resources to match the data loading, data load, right? and it supports like whatever the application or whatever the data processing is being done, those will be done with the help of the like scripting. So it supports like Python, Scala, R language. You can write the implementation logic on any one of this language. Okay, and in the if you speak about Apache Spark, basically all the data, the components of the Apache Spark are divided into RDDs. Okay, so RDD is resilient distribution data set. Okay, so if you talk about the Spark, the basic block of a Spark data or engine is a RDD. Okay, so RDD can be anything. It can be entities, it can be records. So whatever the data you're storing, whatever the processing that you're doing, so that will be stored as a RDD, right? And if you take the latest data frames, some more data frames which are evolved in the future after RDD, like data frames, data sets, those are all built on top of RDD. Now whatever the modern data processing is being done only with the data frames right now, because of its type of the data it supports and the type of flexibility it has. Everybody started using data frames and RDD is no longer being used, but all these are developed based on the RDD only. And operation in Spark performed on in-memory object, which are RDD. So these are all RDDs, like as I said, a basic block. So this is the in-memory object. So whatever the operations processing of the data you are doing, that will be done uh, based on this RDD.
Like lower level of data is RDD.
Right. Who is this? Oh, you joined, Raju?
Yeah.
Okay, yeah. Sorry, you're saying something?
Lower level of data is RDD on top of lower level data.
Yeah, so it's kind of a basic block, the lower level of any data. So on top of which the data frames and are like data sets are developed. Right. So if you speak about the characteristics at the high level of this one, so one is Hadoop, sorry, Spark. So one is the partition. So about sorry RDD characteristics. One is partitioned, split across data nodes in clusters and parallel processing. So whatever the data is given, that split across different data nodes in cluster, and the parallel processing will be performed on the data. And immutable. So once RDDs are created, they cannot be changed. That means, say, suppose on top of one file data, you created an RDD, you cannot change that existing one. So instead of that, you can create one more RDD on top of it by changing the data on that, right? And resilient, can be reconstructed even if a node crashes. So if say suppose if a node crashes in this architecture, say suppose RDD is there, you created multiple RDDs on top of it, like from RDD you created RDD1, then from RDD1 you created RDD2, right? So in that, say suppose one of the node got crashed, still you can reconstruct that RDD by navigating to this tree structure, and you can pinpoint to the original structure that you can do in the Hadoop, Apache Spark. So these are the basic blocks of basic fundamentals of Apache Spark. On top of it, further, the Databricks has been developed, as I mentioned. But from the exam point of view, you don't need to learn much about this, but this is only about for the knowledge purpose. For the exam point of view, only the reading the data using Databricks and some of the components of the Databricks and a cluster mechanism. So those are good enough from the exam point of view, right? So any doubts so far?
No, this is Sudhakar. I'll join late.
Oh, okay. You joined too late. And you joined with your UKG kid
Yeah, my
login.
kid's laptop. Yeah.
Okay. Okay. So we were discussing about only Spark, like some high-level theoretical components about Hadoop, and based on Hadoop, Apache Spark developed, and based on the Apache Spark, the actual Databricks developed. So we're just talking about the different components of Apache Spark, because before understanding Databricks, it will be nice idea to know about some of the basics of Spark, because if you see Synapse Studio, and there also we have a Spark pool, right? So that is the reason, instead of going directly to the Databricks, I started using the Spark, right? So in the Spark components, if you see, basically it has four things: Spark SQL, Spark Streaming, ML, GraphX. So, and here we have like a data frames API, Spark ML, graph processing, streaming. Okay, so data frames, as I mentioned, those are kind of developed on top of RDDS, and this simultaneously provides an abstraction about RDD while simultaneously improving performance 5 to 20 times over traditional RDDs with its Catalyst optimizer. Represents data in rows and columns. So data frame API, what it does is, so whatever the data, underlying data is there, okay, that will be considered in the form of tables like rows and columns, and it has Catalyst optimizer. So we'll talk about what is Catalyst optimizer in the further classes. So Catalyst optimizer, so whenever a query has been given, that will be optimized with respect to the processing engine, so that the processing of the data using data frame will be pretty much faster compared to the RDD. Okay, and using data frame, like when you talk about the data bricks, usually we'll process all the data using data frames. It is one of the powerful component with respect to the Spark. Okay, so in the modern data world, in the data bricks, if you see, all the data processing is being done with the help of the data frames and Spark ML. So one more component is it provides high quality finely tuned machine learning algorithms for processing big data. So for all the machine learning like models develops, we have separate component plus Spark ML. We have the same thing in the Databricks as well. The graph processing API. So this is kind of a different, this is helps for different kinds of data. So where we have like relations like people, objects, nodes, if the data is there in this format, usually we'll go for the graph processing API. So if you talk about myself, I never used that. I never tried to explore, but just it's a good idea to know the like basic understanding what exactly graph processing does. So basically you can say that it's usually used for relationship between the objects, peoples, or between the nodes in the among the nodes in the network. And streaming APIs. So as name itself specifies, so for processing all stream data, this streaming API will be used. So provides end-to-end fault tolerance with exactly one semantics and possibility for some millisecond latency. Okay, so whatever the data comes in the real time, the streaming data, so with the minimal latency, it can process the data. So basically these are the four basic components of the Spark. Okay, now if you see Databricks, now Databricks has been developed on top of Apache Spark, as I mentioned. So Apache Spark is a open source. So Databricks taken the advantage and created this, created Databricks. So what is the disadvantage of the Spark? So infrastructure issues. So whatever the nodes, clusters, or whatever the processing that has been taken care for the data processing, that has to be done everything manually, and infrastructure issues were there. And upgrade challenges, like whenever you want to upgrade the system, that was a challenge. And user interface, one of the main disadvantages, user interface. It does not have proper user interface, like kind of user friendly, where user can go ahead and create the clusters and process the data and all. So it was not having proper user interface, lack of user interface, one of the major disadvantage. And tools integration issues. So in the model data world, there will be so many tools through which you need to integrate your existing architecture to perform various operations, right? So Apache Spark has that issues where there will be issue with the tools integration, and difficulty for the collaboration, because multiple people does the operations same time on the perform the data processing on the data. So there is a difficulty for collaboration among the different users, right? And when you come to Databricks, fully integrated and managed platform for running Spark. So it has, the Databricks has everything like integrated and managed platform. Like everything can be done on the fly, like scaling up can be done, and all the infrastructures can be done on the fly. Okay, it's up. Like it provides everything like infrastructure, interface, everything provides in a single framework. So it basically it's integrated and managed platform. It provides everything whatever is needed with a good interface. And as I mentioned, integrated workspace and UI. So if the set of users can perform the operations on the data using a integrated workspace, and we have good UI where you can manage the data clusters and users, everything you can perform with the help of the integrated workspace. Right now, if you talk about the Azure Databricks, and so it's founded by creator of Apache Spark, Delta Lake, ML Flow. So if you talk about the Databricks, so Databricks has been developed. So whoever developed this Apache Spark, Delta Lake, right, and ML Flow, we'll talk about what is Delta Lake in the further sessions. So the people who developed all this, the same guys created the Databricks, right? And coming to Azure Databricks, is fully developed, managed, cloud-based big data and machine learning platform. So cloud-based, so with the help of Azure, it supports all the cloud-based big data and machine learning platform. So it's very well integrated with the Azure, right? So it can integrate with major Azure data services like ADF, storage, Power BI, Synapse, everything you can connect to that. So if you see here the architecture, the basic high level, so it can help for the data engineers and as well as the data scientist. For the data engineers, it like with the help of, you can connect to a data factory. Suppose you wrote some code, something called notebook. We have interface called notebooks, the components where you write the code, right? So you can write the code with the help of a notebook, and you can call that notebook in the data factory, right? Azure Synapse Analytics, even in the Azure Synapse Analytics also, you can connect to that particular notebooks or Databricks, and you can perform the operation. And Power BI, right? Say suppose your data is resided in the Databricks, the tables, okay, Databricks DBFS, you can connect to that data in the Power BI, and you can perform the operations. Azure Data Lake Storage. Say suppose the data is present in the Azure Data Lake Storage, okay? So without getting the data into the Databricks, you can connect to that, you can mount the data, the ADLS on your Databricks, then you can perform all the operations over there. Okay, so it's for all the data integration data engineers, you can connect to multiple Azure data services where you can process the data. And for ML data scientists, like it supports like ML flow, machine learning flow, and Azure machine learning with the help of various tools like PyTorch, TensorFlow, Stickland. These are all kind of different tools for processing ML runtime. So it supports equally to the data scientist as well. So it supports data engineers and data scientists as well. That is that makes that is the reason it makes one of the powerful tool. Okay, and we have optimized Databricks runtime engine, so it has like serverless, and we have Apache Spark runtime engine which is optimized with the help with its structure, and we have a Delta Lake structure. It supports a Delta Lake. Delta Lake is nothing but it's a kind of a data lake, but all the transactions can be performed on top of the data lake data. So it's kind of, if you say high level, all the acid properties can be applied to the data which is present in the data lake. So that makes the delta lake. Now whatever the data processing is being done in the modern data world, all those are done on top of delta lake. And Databricks IO. So the runtime engine has also Databricks input output engine, which takes care of all the data processing mechanism. So in the nutshell, this is about the Databricks at the high level. So in the coming session, we will try to create a Databricks what is a Databricks resource from the Azure, and there we'll try to ingest the data. We'll connect to one of the data lake, and we'll process the data using data frames. Right? From the exam point of view, this should be good enough. Like creating the clusters and understanding the underlying architecture and processing the data. But if you see the Databricks, it's altogether different course. If you want to know in and out, it almost takes like 2 to 3 weeks. Okay, but whatever is useful from exam point of view, from interview point of view, I'll be going through that. And even some of the things like query optimizer and analyzer, lazy evaluation, those still I will discuss, even though those are not being discussed as part of the exam. Okay, so let me